Hi guys, welcome to Know Math. My name is Sir Bench Antonio, and in this video we will discuss geometric series. This lesson is intended for high school mathematics, especially for grade 10 students. If you are not yet subscribed on my channel, please do not forget to hit like and subscribe for more of my videos. And of course, for you to get notified once I uploaded my new video. So let us review first what are the lessons that we have regarding the series. So these are the lesson for the arithmetic series. So we have this video about this arithmetic series. We have these formulas that we are using when we are solving some problems involving the arithmetic series. The first formula is for finite arithmetic series, and the second formula is for the infinite arithmetic series. The same thing with the geometric series. We also have these different formulas that we will going to use for us to solve some problems that involves geometric series. So we have here some formulas for finite geometric series and the formula for the infinite geometric series. So I will explain some of the differences between those formulas on the examples that we will going to have. Let us have for the first example. Find the sum of the first 6 terms of the geometric sequence 3, -6, and -12. First, let us show the given. What are the given on that problem? First is we need to find the sum of the first 6 terms. So, meaning that is what we are going to solve. And in the given sequence 3, -6, -12, it is obvious that we have the first term of 3 and we have this value of the common ratio. The common ratio that we have is we are multiplying by -2 on each of the term. And of course, since the series of 6 terms is what we are going to solve, meaning the n value is already given, or the number of terms is already given, which is 6. So let us show the formulas that we are going to use. So the difference between these formulas, on the first row, we will going to use this formula if the n value is given. If the n value is given, we will use these formulas. But there are two formulas. The difference between those formulas, the first one is we're going to use if your common ratio is greater than 1, or the absolute value of the given common ratio is greater than 1. And for the second formula, we will use this if the absolute value of the common ratio is less than 1. So, since the n value is given here, we will use these first row formulas. But what formula are we going to use? So we will now check the absolute value of our common ratio. The absolute value of our common ratio here is 2. So since 2 is greater than 1, we will now use this formula for the given problem. So let us now rewrite. The series of n terms is equal to a sub 1 multiplied by the common ratio raised to the number of terms minus 1 divided by common ratio minus 1. By substituting the given, we have here the series of 6 terms. And the first term is 3 multiplied by the common ratio of -2 raised to the n, which is 6, then minus 1 divided by the common ratio of -2 minus 1. So in this case, we can now evaluate. The series of 6 terms is equal now to 3 multiplied by -2 raised to the 6th power. That will give us 30 or 64 minus 1 multiplied, divided by -3. as negative 2 minus 1. That will give us negative 3. So in this case, we have 3. 64 minus 1 is 63 divided by negative 3. So either of which you can use, or you can perform. You can perform first 3 divided by negative 3. That will give us negative 1 times 63. Or the other one, you can divide 63 by negative 3, and that will give you negative 21. So if we're going to solve this problem, the same answer, or we will arrive on the same answer, that will give us negative 63, and that is now the series of 6 terms. So either way, you can perform. You can divide first the first factor 3 to the negative 3, or 63 to the negative 3. We can still have the same answer as negative 63. Let us try another example. Find the sum of the geometric sequence which the first term is 125, the last term is 1/5, and the common ratio is 1/5. So, on the formula guide that we have, as we have said, that we are using the first row formulas if n is given. When we're going to use these second row formulas, the second row formulas, we can use this if the last term is given. As on the formula we have here a sub n. We do not have the n value, so that we will use the second formula. Take note, the difference between the two formulas, we will use the first row formulas given that the absolute value of r is greater or less than 1. We will use this first row if n of the number or the number of terms is given. And the second row formulas, we will use this if the last term is given. Since on the second problem, the last term is already given, which is 1/5. So we will use the second row formulas. But which of these two formulas are we going to use? Now, let us show first the given. Find the sum of the geometric sequence which the first term is 125, the last term is 1/5, and the common ratio of 1/5. So we already know that we were going to use the second row formulas as the last term is given, but which of these two? Let's check the absolute value of the common ratio, which is 1/5, and 1/5 is less than 1. So we will now use the second formula for the second row, and that is S sub n is equal to a sub 1 minus a sub n times r divided by 1 minus r. Actually, even or either of the formulas, you can also use the other formula even if it is less than or greater than 1. It is just that we are doing these two types of formula for the students not to be confused what formula they are going to use. If the common ratio is greater than 1, or if the absolute value of the common ratio is less than 1. It is more easier if we're going to interchange the r and 1 on the denominator. So that if r is less than 1, we can just subtract that less than 1 from 1. And if we're going to interchange it as r minus 1, if r is greater than 1, it is easier to subtract. Okay? So, let us now substitute the given values. So, the series of n terms, which is we don't know, how many terms do we have, but the last term is already given. A sub 1 is given, which is 125, minus the product of the last term and the common ratio. The last term is 1/5, and the common ratio is also 1/5, divided by 1 minus 1/5. So to continue, we have here the series of n terms is equal to 125 minus 1 over 25 as the product of 1/5 and 1/5, divided by 1 minus 1/5, that will give us 4/5. Right? Subtraction of fraction. Let us evaluate. We have here now 125 minus 1 over 25. So if we are going to use the process of subtracting fractions, whole number to fraction, that we need to get first their least common denominator, which is 25. So 25 divided by 1, as we have here an imaginary 1, 25 divided by 1 is 25. Then times 125, we have 3,125. Minus 25 divided by 25 is 1, times 1, we have 1. All over 4/5. Alright, continue. 325 minus 1 is, or 3,125 minus 1 is 3,124, divided by 25, all over 4/5. That's 4/5. So I'm having a problem with my pen. Let's just slash 4/5. Alright. So by dividing fraction, we all know that the rule in dividing fraction is, first we need to get the reciprocal of our denominator, which is 4/5. So its reciprocal is 5 over 4. So upon getting its reciprocal, that is 5 over 4, and we have here 3,124 divided by 25. We will now proceed to multiplication. And on that case, if we are now on that part, we can use the cancellation process. We can simplify 5 and 25, that will give us 1 and 5. We can also simplify 3,124 and 4, that will give us 1 for 4, and here is 781. So that we can simply multiply the two fractions. 781 times 1 is 781, and 5 times 1 is 5. Therefore, the series of the n terms that we have is now 781 over 5. So the thing that you must know, or you must recall in terms of the foundation of mathematics for you to easily solve this kind of problem, is your knowledge in operating fractions. Okay, so how to add fractions, how to subtract fractions, multiply and divide fractions, because there are some given which are fraction. So just like this example, we have this last term of 1/5, and we have the common ratio of 1/5. Next, example 3. Find the sum of an infinite geometric sequence 1 plus 1/5 plus 1 over 25 plus and so on, if it exists. So, in the formula guide that we have this one formula only for the infinite geometric sequence, which is the partial sum of the given series, that is geometric series. It is equal to the first term divided by 1 minus the common ratio. It is the only formula for the infinite geometric series. But we also need to know what is the absolute value of the given common ratio. It is very important. If the absolute value of the common ratio is less than 1, then the given geometric series converges, meaning it is existing, or we can solve the given geometric series. But if the common ratio or the absolute value of the common ratio of the given geometric series is equal to 1 or greater than 1, then the series diverges, or it is a divergent geometric series. I mean divergent geometric series. Then we cannot solve the given geometric series. There's no solution because it doesn't exist. Take note always that the r should not be always equal to 1. That's why if r is equal to 1, it doesn't exist because it will just become 0. As if we have 0 in our denominator here, we cannot solve. It is undefined. Okay? Now, let us find first let us have first the given on the problem. The first term is 1 because that is one element that we need on the formula. And the common ratio, as we all know, it is a sub 2 divided by a sub 1. As it is a fraction, I just wanted to explain how we're going to get this common ratio of the given series, as it is a fraction. So we have 1/5 over 1. That if we have a whole number, when we are dividing fraction and 1 is a whole number, let's make it a fraction by having a denominator of 1 for us to easily divide the two fractions. So we have now 1/5 multiplied by 1 over 1, as it is the same with its reciprocal, 1 over 1. So let us multiply. 1 times 1 is 1, 5 times 1 is 5. So now the common ratio is 1/5. Okay? So since the common ratio is 1/5, we have these two conditions. First is if it is less than 1, or the absolute value of the common ratio is less than 1, it does exist. But if the common ratio or the absolute value of the common ratio is greater or equal to 1, it doesn't exist. So therefore, since 1/5 is less than 1, it does exist. We have this solution. Okay? So therefore, the series converges. So let us solve, as the formula of the given partial sum of the geometric series is equal to the first term over 1 minus r. We have here the first term of 1, and we have here 1 minus the common ratio of 1/5. So 1 minus 1/5 is 4/5. So again, we have a whole number. In dividing fraction, it is more easier to divide fraction versus fraction. So the whole number, let's make it a fraction, like having a denominator of 1. So let's make it 1 over 1. Then get the reciprocal of the denominator, which is 4/5, and that is 5 over 4. And then we will proceed with the multiplication part. So 1 times 5, we have 5, and 1 times 4, we have 4. Therefore, the partial sum of the given infinite geometric sequence is 5 over 4. Let us try another example. Find the sum of an infinite geometric sequence 4 plus 12 plus 36 plus and so on, if it exists. So let us review again the formula that we will going to use in the infinite geometric series. We have here the elements that we need, a sub 1 and r. The a sub 1 is 4, and the common ratio is Observe that we are multiplying 3 on each of the terms, so r is 3. So we need to know which are we going to apply. If the absolute value of r is less than 1 or if the absolute value of r is greater or equal to 1. Since that r, or the common ratio, is greater than 1 because it is 3, the series diverges. Then it doesn't exist. So we can conclude that the sum cannot be determined. So there's no solution needed because we cannot determine the given sum. Okay? Let us try another example. Find the sum of, or find the series of 8 terms of the given geometric series 8 plus 16 plus 32. So let us have the given, the series of 8 terms, which is we need to solve. The first term, which is 8. Next is the common ratio, which is multiplying by positive 2. So these are the given that we have. And of course, since the series of 8 terms is what we are looking for, the n is given because we have 8 terms. Okay? So on the formula of the finite geometric series, if n is given, we will use the first row formulas. But which of these formulas? Check the value of r, which is greater than 1. So we will use this formula. Okay? So the series of n terms is equal to a sub 1 multiplied by the common ratio raised to n minus 1 over r minus 1. Substitute the given. The series of 8 terms is equal to 8 multiplied by your r, which is 2, raised to the n value, which is 8, minus 1 over 2 minus 1. So evaluate. 8 multiplied by 2 raised to the 8th power, that will give us 256. Minus 1 over 1, as we have 2 minus 1. So basically, we don't need this one, as we have now 8 multiplied by 255. Alright? So what is 8 times 255? Let us multiply. Let's multiply. We have 255 times 8. Just like an elementary level, we have 0, carry 4, 40. We have 44, carry 4. We have 8 times 2 is 16, plus 4 is 20. Therefore, we have now 2040 as the series of 8 terms. Just for the guide. Okay. Another example, number 6. Find the sum of an infinite geometric sequence, 7 plus 28 plus 112 plus and so on, if it exists. Actually, this is a geometric series already. So, infinite formula. So, very basic. Let's just know what is the value of r, so that we have to know its absolute value if it is greater than 1 or equal or greater than 1 or less than 1. So what is r? Our r value is, observe that in each of every term, we are multiplying by positive 4. Since that it is greater than 1, therefore, it doesn't exist. So, we can conclude, since the absolute value of the given common ratio is greater or equal to 1, the series diverges. Therefore, the sum cannot be determined, or it doesn't exist. Last example. Find the sum of an infinite geometric sequence 4, 2, 1, or 4 plus 2 plus 1 plus and so on if it exists. So, for the formula, let's find the r value. The r value is 1/2. We are multiplying each of the term by 1/2. Therefore, it is less than, or the absolute value is less than 1. So, it exists. So, we can find the partial sum. Let us find the first term. First term is, or determine the first term is positive 4. Using the formula, we have here a sub 1 over 1 minus r. Substitute. The partial sum, we do not have n as we are finding the partial sum. The partial sum is equal to the 4 over 1 minus 1 half. So that is 4 over 1 minus 1 half is simply 1 half. Again, 4 is a whole number. Let's make it a fraction by having a denominator of 1. And then get the reciprocal of the denominator, 1 half, which is 2 over 1. Proceed to the multiplication of fraction. 4 times 2 is 8. 1 times 1 is 1, or simply 8. And this is now the partial sum of the given infinite geometric series. So, that is all for the geometric series. I have this math challenge for you. If you know the answer, just comment down below. Find the sum or the series of 29 terms of the geometric series 17 plus negative 17 plus 17 plus negative 17 plus and so on. And do not forget to hit like and subscribe for more of my videos and for you to get notified once I uploaded my new video. Thank you for watching.